Yeah, so I will provide you like full solutions to every question in the 2022 AP Calculus AB FRQ. So you just like recently took, and yeah, I hope you enjoy this. Now, I like say this problem is the last one that I did, perhaps because like I'm a theoretical math person more of, and so these application questions are like of the least interest to me, and I find the no calculator sections, ooh, like no calculator section. See, I'm not lying. Like I did it back, like starting with problem two actually, to be honest. But yeah, no, I prefer the no calculator section problem. So I like started there basically. So if you wanted like a more thorough introduction, like I know you need more than this. Like like you should start with problem two and stuff. But because yeah, like but anyway, let's get to it. Yeah, okay. Yeah, video dedicated to Jesus Christ, God, like my love, my everything, and otherwise, yeah. So let's get to it. Right, but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza. Like, oh yeah, like you read it, so like I'm not gonna read the rest of them, but like, so A of t is supposed to be what? The rate at which vehicles arrive. That's A of t. So we want to take the integral of this A of t from even though it started with 5 a.m. is like time go, like, right. And so that's zero, as they say, like 6 is like 1, right? So like we could just use 1 to 5 to correspond to the 2 times of concern, right? 10 a.m. and you know what. All right, so and then dt, right? Now this is a calculator section question, so it's up to you to like figure out what number this comes out to in your calculator. And sine, and then 0.62 t, and then to the 1 power dt. Like you figure out what this comes out to. Yeah, okay, cool. Let's keep it moving. Part B. Okay, so like basically they're asking us to find the average value of a of t. Now we know for any function on an interval ab, the average value is 1 over b minus a times the integral from a to b of whatever function of concern, right? F of t or f of x. Let's write it for x, and that was sloppy, so let's do that. Okay, yeah. Okay, so in this case then we're going to have to write 1 over 5 minus 1, so that's 4, right? Like, so 1 over 4, and then integral from 1 to 5, and then, like, otherwise, A of t, so A of t dt, is there anything else to it? Find the average value of the rate in vehicles per hour. Yeah, actually, like, it's puzzlingly simple, right? Like, yeah. So like the job is to the calculator, right? So you figure out what number that comes out to. It's not important to me. Okay, let's keep it moving. Next part is the rate at which vehicles arrive. So that's A of t. Is that increasing or decreasing? So if we want to know if a function is increasing or decreasing, we want to look at its derivative. So in this case, that would be a prime of t. So a prime of t, notice, is going to be 450 over 2, and then sine of 0.62 t to the negative 1/2. So I got that over 2 here because I saw the square root as a 1/2 exponent. And so that means then we'd have to take the 1/2 and multiply to the 450, giving us 450 over 2, right? And then negative 1/2 there, right? Okay, and then cosine of 0.62 t, and then times 0.62, right? And this is an application of chain rule. Now, this is a prime, and we are interested in t equals 1, right? So we want to know if a prime of 1, so this is just plugging in numbers, right? And like cosine of 0.62 times 1, right? And then times 0.62, and then this is divided by 2 times sine of right? And this is to the 1/2, and this whole numerator is multiplied by 450, right? To figure out what that number is. And if it's less than 0, then it's decreasing. If it's greater than 0, then it's increasing, right? And that's all there is to it. Okay, so to start, I have underlined a couple of like useful, consistent phrases there, and like they're in reference to this N of T function, right? It's the number of vehicles in line, right? Now, and we're considering this interval where the constant A is unknown, but we are told that a line starts to form when A of T is greater or equal to 400. It's greater or equal to also, right? Okay, so we see that like this A here, which is the time when the line first begins to form, must be whenever A of T is equal to 400, right? So we write that, got it. And then, in addition, we know that since what we're being asked for is like greatest global maximum, right? That we need to find where n prime of t is equal to 0. But then n prime of t is equal to d dt of the integral from a to t of a of x minus 400, right? And by the fundamental theorem of calculus, the only fundamental theorem of calculus, we see that n prime of t is going to have to be equal to a of t minus 400, right? Okay, cool. Now we set this equal to 0. Notice that this amounts to a of t is equal to 400, which means that like basically the like equation we'd have to write to figure out what this a is, which is crucial to do. We need to know what a is to answer the question here. The equation we have to set there is the same as the one we'd have to set to find like critical numbers for n of t, right? Okay, all right. So if you do it correctly, it turns out that those values are going to be t equals 1.46. That's a, and then t equals 3.59, and like their values, like to figure out what n of these t values is, we'd have to write the following integrals, right? So let's do that. Since global maxes require like considering what happens at the endpoints, we also need to consider the other endpoint 4, right? But this 1.46, which we got from a of t, it equals 400, right? Which again is what n prime of t equaling 0 reduces to, right? This here is a, right? But yeah, like now we need to figure out the value of n for each of these guys, right? So now to do n of a, it would have to be, by the definition of n, it would have to be the integral from a to a, and the integral from a to a, doesn't matter what's inside it, is equal to 0. So this is going to equal 0. Alright, now for n of 3.59, we'd have to write the integral from a, which is 1.46, to 3.59 of what? A of x, which is this function here, right? So you'd have to do this in your calculator, clearly, minus 400. And if you do it correctly, you should find that this is going to come out to 71-ish, right? And then finally, you're going to have to do n of 4, and that's going to mean you write integral from 1.46, that's a, to 4 of, once again, a of x minus 400 dx. And upon doing this, you should learn that you've got approximately 62.3. And so then, since you're asked for the greatest, it's going to be an approximately t equals 3.59, and it's going to be 71. And you know, I'm sure you, like, when you were studying, saw a scoring guideline to learn that you got to use like appropriate units, and you got to use appropriate decimal places, and what care to do that. Really, like, I barely touched on calculator. Well, yeah. All right. yeah, I hope you enjoyed this, but like, yeah, you'll have a lot more fun in what is to come and the remainder. And yeah, keep watching. Take care. Well, for now. Problem 3 to come. On. Hey guys, welcome. So, in this video, well, oh yeah, shoot, I'm recording starting with problem 2. So like, this is supposed to be like the intro, but can't be really because it's problem 2, right? But anyway, like on the 8th, I recorded a video to help you prepare for the test on the 9th, and like it was not helpful because I didn't get to post it by the 9th, but I'm still gonna post it because it's like hilarious, right? So you should watch it for like other reasons than the math, and it's also very educational as I will attempt to make this video. So let's start by giving thanks to Father, the Son, and the Holy Spirit, God, Jesus Christ. I was gonna pose with a riddle because somebody called me a riddler. I don't know what a riddler is, but yeah, I know some riddles, and like, there's nothing funny about like writing riddle about God because it's not a riddle. His name is Jesus Christ. Get to know him. But here's a riddle. All right, before we start solving problems, what do you call the filthiest, like worthless, low, pathetic loser in the world? A Freemason. Only there's nothing free about them. They're like chained by the devil, like because their god is like Satan, and like they like try to mess with me all the time. But I'm having a blast because they're hurting. The op is hurting, and this is just the beginning. All right. So like this is the beginning of problem 2. So let's get on with it. All right. Cool. So as I like did in that like solution set that I alluded to a little bit ago, like what is it? I assume that you read the questions and such, so we could just get on with this, okay? So like in A it says find the area of the region enclosed by the graph of f and g. So this is a simple area between two curves, right? So we know that like the area between two curves is going to be the integral of hold on, I got it like okay. The integral of like the top function, which we know is f, and I'll tell you why, like, and then minus the bottom function, which we know to be g here, right? And the reason we know this, and by the way, from -2 to, like, I'll write it as b. That's what they referenced it as right here. And we'll talk a little bit about the limits of integration in a second, but I know f is a top function because, hold on, like, let me switch my pen. Oh, shoot. All right. I know f is a top function because, well, we know what logarithms look like. They're like this, right? And it's clearly shifted like 2 units or 3 units to 3 units to the left, right? Because this like 0 is typically on log x right there, right? Okay. All right. But anyway, like, there are many ways to tell why, like, this is f. Hold on, we remove that drawing. Okay, f and therefore this is g. Got it. G's like a polynomial. We got it. Looks like a polynomial and such, right? Okay. So, but otherwise, this is pretty straightforward. As I said, I will say a little bit more about the limits of integration. So the limits of integration when we're doing area between two curves is from the x corresponding to, like, the left most point of intersection to the x corresponding to the rightmost, right? And so like like this one is pretty clear and they tell us, right? And the other one they say is b, right? And like the way we find them, right, like is like by setting like the two functions f and g equal, right? And so f of x equals g of x, right? And like clearly then you have to set this thing equal to this thing, and that's a job for the calculator, and that's how you're gonna get to like the value of b. You can quickly see that -2x equals -2 make them equal. Both f of -2 and g of -2 are 0. And a first recording of this, which I like lost for whatever reason, I'm gonna assume Freemasons, because like they hack into my computer and like they try to mess, because like I show them zero respect. They like do all kinds of stuff to mess with me, and like I only double down. because I don't respect them at all. Anyway, they're just like so filthy and low and dirty and like basically everything I already said. Let's keep going. Okay, so f of -2 is equal to g of -2, and yeah, so like that checks out, and so b has to also similarly abide by that, right? It's got to make f and g equal to each other, but that's for the calculator. So is everything else I have left, right? Which is all I'm gonna write now is hold on, let me do it down below where I can erase oh, and I didn't need this right here, right? So like we're doing a still. Darn, I dwelt on this. We'll keep it moving faster, I promise. So -2 to and then b, right? And f we have, right, ln of x plus 3 if you really need me to write this, right? And then minus g, so the minus sign will be distributed, and then it'll be like x to the 4th minus 2x cubed, right? And then a dx here, right? And then you're done, right? And this integral is to be done in your calculator, as is figuring out what b is, right? Okay. All right, let's keep it moving. Okay, so as I said already, you've done the reading, right? And so they tell us h is a vertical distance between f and g. So they must be talking generically, say, for something like that. That's h, got it. Is h increasing? First of all, what is h? H is equal to, clearly, h is equal to f minus g. We just written that, right? So that's ln of x plus 3 and then minus x to the 4th and then minus 2x cubed, right? That's f minus g and therefore h. And they're asking us, is h increasing or decreasing? Whenever we want to know if a function is increasing or decreasing, we always look at the derivative, right? So we're like d dx of, got it. And so, what does that look like? That's pretty straightforward, right? So it's 1 over x plus 3, and then minus, it's 4x cubed, right? And then minus 6x, right? And they're asking us where, and it's at -1/2, so x is -1/2, right? And so you could power through, just without a calculator. For example, you're going to write 1 over -1/2 plus 3, that's 3.5, that's what, 5 over 2, right? 3.5 is 5 over 2, right? Something like, no, 7 over 2. So we're going to be like, Jesus Christ. All right, 7 over 2, and so that's going to turn into 2 over 7 and stuff, right? And so you could similarly evaluate the rest of the parts, right? And be like, you're done, right? Or you could just plug it into your calculator, and either way you get it done is fine. This is pretty straightforward. Just find the derivative of the function, which defines the difference between f and g, and in that derivative, plug in a -1/2, and yeah, spit out a number, right? Okay, cool. So let's keep it moving. So yeah, for part C, big picture, the thing to keep in mind, right, is that volume is the integral of area, right? And the cross sections are perpendicular to the x-axis, so we want the area function to be of x, right? And that also means we're adding horizontally, so the differentials are dx. The delta x is turned into a continuous variable are going to be dx's, right? Because we're moving horizontally, right? Okay. But otherwise, as far as cross-section volumes rather, cross-section volumes are concerned, this is a very straightforward question, because, well, if we just finish off one generic cross-section of the solid that would be formed, then it's going to look like this, right? It's going to be coming out of the screen, and it's going to look like this, where all corners are 90 degrees, right? Okay, cool. So then with this, we go, fine, the volume V is going to be equal to, from, that integral sign was super ugly. From -2, much better, to B, once again, you would have found out B was in part A or somewhere earlier, right? Okay, so the other point of intersection of F and G, right? Set them equal F and G, and your calculator will solve, right? Okay. But then hold on. The area is it's a square, so it's very straightforward. So this is S here, and this is S here, so the area is S squared, right? And so, but then S is the difference between F and G, right? So S is equal to F minus G. Once again, when you do that, you have to make sure that in G you distribute a minus sign here and there, right? After and F is like just write it and then do that, right? But outside of that, like right, all you have to do is put F and G right here. And so F minus G in that order, and then square, and then dx. Like clearly F and G are both in terms of x. So I need to say any more here, right? Okay, find the volume of the solid. The rest of the job is for the calculator. You would have known what B is. You know F and G, so type it into your calculator. Don't forget to put parentheses around them. And don't forget, like F minus G is going to be ln of x plus 3. I needn't have to write. But I needn't have to write it, right? Okay, there we go. All right, that's some sloppy handwriting. I probably shouldn't have written it, but I get to get rid of it like that. Okay, let's keep it moving. Hey, so like in part D, right? Like there's a vertical line that's like moving from left to right, right? And this vertical line, right, like is in our region, right? And so the vertical line that they have to be talking about has to be like this vertical line that's right there, or if it's over here, it's like this much wider, but still like vertical line, right? Because otherwise, it's like, what vertical line are you talking about, right? Like, and it's moving from left to right. Got it. But now that left to right movement is telling us a rate concerning a horizontal movement, right? And so let's just consider that the x direction, right? Because it is along x, right? And so we're like, all right, so oh no, that's not what I wanted to do. Hold on. So there's like the line is moving from left. Christ, I used a ruler for the arrow and missed the arrow. How? Like so. All right. So left to right. So let's say arrow saying 7 units, like so per second, right? 7 units per second. Let's say 7u. All right. So got it. And it's positive. Like, well, because it's moving from left to right for no other reason. Because usually, related rates questions, we'd have like, a rate for the base, and let's say you're going this way, that's positive. If you're coming down, that's negative. And the formula that would relate them would be the Pythagorean theorem and all that good stuff, right? And so, do we have a formula that relates them here is the question. And so, because we don't know if it's going, so just by its left to right movement, we'll say it's positive 7, right? Now, so what is the question in the end? It's find the rate of change of the area. Okay, cool. So this is about area. Got it. So it means that we want to write a is equal to, right, s squared, right? But like having recognized that this is a related rates question, we know that we need to write like dA dt, right? Notice the right hand side would then have to be 2s ds dt, right? But wait, what is ds dt? Right? Because s is defined vertically, right? Like, and so that's not what we want. Like, we want dA dt, right? Like, and we can't get to dA dt without knowing ds dt, and moreover, s ds dt would define some vertical rate, right? And the rate we're given is the horizontal rate. So we got to somehow like make it about a and x, because the 7 we set aside to represent a dx dt, right? So we're like, this is like a dx dt, got it. So then dA dt is going to equal, like, since s squared is going to have us write that a is equal to s's f minus g. So that's ln of x plus 3 minus x to the 4th minus 2x cubed. So I needed some space. So dA dt is going to be equal to, what is it going to be? 2 times, and then it's ln of x plus 3 minus x to the 4th minus 2x cubed to the 1st. I'm applying chain rule. And then the derivative of, like, let me get rid of a little bit of something. Okay. Alright, so, and then by chain rule, we want to multiply by the derivative of the inside, right? So that's going to be 1 over x plus 3, and then dx dt, right? Okay, and then minus 4x cubed dx dt, and then minus 6x squared dx dt, right? And so then you can factor out a dx dt for convenience, but since what we want is the areas change, right? When the vertical line is a position x equals -1/2. Well, notice that like if you plug in -1/2 for all the x's here, that's just a number. And this is a number, this is a number, this is a number, just for similar reasons. Dx dt were given. So all you have to do is like a lot of number crunching, and I don't see where I come in for that. So I'm done with this part. Okay, cool. Keep watching. Problem 3 to come. Prime, right there, and on the interval 0 to 7, right? But yeah, like the information here we're given is about f, and the information that is sought after in these two parts is also about f. Now, we could, by integrating a semicircle, you know, the equation that would define the semicircle, by integrating a semicircle that's below the x-axis as is clearly, right? But like, I mean actually like from like, hold on, like let's just write it real quick, right? Like, so it'd have to be like, what is it? It would be x minus h to the center, x minus 2 squared, and then plus y squared is equal to 4. This defines, well, okay, so then y would have to be square root of 4 minus x minus 2 squared. I don't even know why I'm doing this. Just like, and so it would have been a plus or minus. You'd have to choose the minus because it's a semicircle below the x-axis. By integrating this, so, and like throwing an integral over this, right? Like from, like we can say 0 to x, right? And like, so letting that be the first piece and then having a second piece and a third piece, we can get to f. But that's not the way you're intended to get there, right? Like it's intended, it's not an English lesson. That's not what's intended here. What's intended here is you use that same like evaluation theorem like trick, right? Which is like here, if we write like the integral, right, of f prime, well, first we have to write 4 here. Usually they give you this, right? They'll be like 4 to x, and that's what they would have written here. But you know, you're expected to come up with it. So the integral from 4 to x of f prime dx, this is going, not f prime, well, it's f prime of x, sure, but like dx is what I had intended to write. This would have to be f of x minus f of 4, right? And this is what we call the evaluation theorem, right? The integral from a to b of f dx is equal to f of b minus f of a. That's what's called the evaluation theorem, right? F of b minus f of a. I wrote b twice, but you get it. Okay, tend to erase all of this. Got it? Okay. But like, you know, so that's what I just wrote, like making it abundantly clear. So then using this, then we could like get to f of 0, for example. F of 0 would have to be, well, we want this to be the f of 0. So we would write like, to start on the left side, to get 0 involved, to get it in the game period, we have to write 4 to 0 rather. 4 to 0, f prime of x dx, right? And so this would have to be f of 0 minus f of 4, right? And so then it's clear that that f of 0 would have to equal f of 4, and then plus the integral from 4 to 0 f prime dx. Now we can interpret this integral to be the area bounded by f prime, the graph we have, and the x-axis only. Like, we can't make sense of it like that if this number is bigger than that number. So we use that same old, like, you know, integral property, which is we could just put a negative sign right there. Ooh, what an ugly integral sign, and then put 0 here and 4 here and f prime here and then dx here, right? So we're like, oh yeah, cool. So then so all I did is like swap here the limits of integration by throwing a negative sign. Everything else, we're good, right? So we go f of 0 is equal to f of 4 we know is 3. That's why I highlighted that given to start. So 3 minus what? Minus the integral from 0 to 4 is this negative number that represents the area of the semicircular region right there. That's below the x-axis. Well, so the semicircular region is pi r squared over 2, but it's r is 2, so pi 2 squared over 2 is what we get. That's 4 pi over 2, that's 2 pi. But remember, this is perhaps a detail I missed last time out. This is going to have to be or when I was doing this first looking at it, this is going to have to be a negative number because the area is below the x-axis. So it's going to end up being 3 plus 2 pi actually, right? Okay. So f of 0 is equal to 3 plus 2 pi, right? Because it's f of 4, and then this minus came from having to swap the limits from 4 to 0. Well, I'll do it here from 4 to 0. So then the minus 2 pi has to be the value. So f of 0 is 3 plus 2 pi, right? And we're going to need it for a later part, so we'll leave that somewhere safe. And you'll see that we're going to need f of 5 later also. So this is, okay, but f of 5 will be a lot quicker, right, to get to, right? Okay, so let's do it. To get to f of 5, we will want to write 4 to 5 of f prime dx and write that this is equal to f of 5 minus f of 4, right? So we're just using this here, right? Okay, cool. So then f of 5 is equal to f of 4 plus the integral from 4 to 5. And this is 3. So we go 3 plus, the integral from 4 to 5 is the area of this triangular region right here. So that's 1/2, base is 1, height is 1. So this is 3 and 1/2. So we write that somewhere to pick up later also. Alright, this concludes part A, and so let's continue on to part B. Did I tell you how much I hate these despicable losers called Freemasons? They won't leave me alone. And in an ideal world, instead of filming a calculus video, I would like to be a Freemason assassin. That's my dream job. I would like to personally execute every Freemason on Earth.
Truest words ever spoken.
Okay, so in part B, we have to figure out all points of inflection for f. So points of inflection are places where f double prime is equal to 0, right? Or places where f double prime does not exist. And these are just ways to identify potential points of inflection. To actually decide if they are points of inflection, we put these on a number line and test numbers on either side of them. The number line is for x values, right? But we'll label it for f double prime. But we test x values on either side of them into f double prime to see if f double prime goes from positive to negative or the other way around, from negative to positive. Because if it does not do that, then they're not points of inflection, right? Now, since this graph is for f prime, f double prime would be the slope of f prime. So we'd want to pick out any places where f prime has slope equal to 0, that is a horizontal tangent. There's that there right there. And so that's x equals 2. But we also want to identify places where f double prime will be undefined. And that's any sharp turning point for f prime, because on sharp turning points, f prime will not have a derivative, and therefore the derivative from the left and the derivative from the right are not going to be the same. And so it'll be f double prime does not exist, right? So that's x equals 4 and x equals 6, right? Okay, cool. So x equals 4 and then x equals 6. The only thing that remains is to test to test, well, we don't have a function f double prime to test points about either any of these, but we have the graph of f and we can do a slope analysis, right? So about x equals 2, the graph of f, I'll do it in blue, goes from negatively sloped to positively sloped. So since, again, the slope is of f prime is talking, so I think I misspoke once or twice, said f, but I meant f prime. The slope of f prime is speaking of f double prime, right? It's about f double prime. So f double prime goes from negative, because the slope of f prime is negative there via that random tangent line, and then went to positive. So negative to positive, got it. And then about x equals 4 is from positive to positive. Okay, no good, right? Because this is positive, but that line is clearly positively sloped. And the x equals 6 is from positive to negative, right? On either side of it. So cool. So yeah, there are 2 points of inflection. They occur at x equals 2 and x equals 6. And they only asked us for x coordinates, so we're done. Interval, right? Okay, so the analysis. So we want to know where g prime is less than 0, right? And so, like, that's what g decreasing amounts to. G prime is less than 0, right? So we need to figure out what g prime is. G prime of x is going to have to equal f prime of x minus 1, right? Okay, so what in the world is this talking about? That would be like if every point was projected down 1. So like the line would look like this, and it would peak out on vertically at 1, and the point 7,1 would shift down to 7,0, right? And so instead of 6,2, it'd be like 6,1 and such, right? Okay, you get it. Instead of 0,0, it'd be like 0, -1 and such, right? So that's what this is telling us. It's just take f prime and shift it down 1, right? That's all we take out of that. Didn't want to do me. Okay, so what? So then this function g, whose derivative is given by basically my red dotted outline, if you like made them solid, right? That g prime, right? If it's less than 0, anywhere it's less than 0, then g is decreasing, right? And notice that other than this little sliver, like right here, right? Between 5 and 7, everywhere else, like g prime, my dotted red line, right, is below the x-axis, and that's what we mean by less than 0, right? G prime being less than 0, is it below the x-axis, the graph of g prime, right? Okay, and then okay, I think I said enough. So like it's between 0 and 5, right? Okay, cool. That's it. And yeah, for this part, use specifically f of 0, which they had us find in part A, and if your memory is as good as mine, you'll know it was 2 pi plus 3, and we also have written f of, f of 5, right? And it was 3 and 1/2, right? Okay, cool. Because we're going to need them. In part D, it says for the function g defined, right? And g was defined as f minus x, right? G of x is f of x minus x, right? And so it was in part C, and yeah, okay. Find the absolute minimum value of that function g, right? And so, fine, remember, for absolute minimum values and maximum values, we need to create a table. Well, we don't need to create a table, but we need to figure out the critical numbers, right? And those are where the derivative is equal to 0. And then together, we need to put those x values and the x values on the end cap of the interval, at the end of the interval, and consider which of them puts out the largest value on the original function g, not its derivative, but in the original function g. The only time the derivative is concerned is in helping us identify the critical numbers, right? So first, let's put 0 and 7, because, well, they're both endpoints, so we know we need to consider their value for g of x, which, remember, was f of x minus x. Well, that's not the place to write it, so hold on. I'll just write it simply as f minus x, right? Okay, cool. So now, what is the value of g at 0? So g of 0, we would have to be equal to f of 0 minus 0, because g of x is f of x minus x, right? And so then f of 0 we already calculated was 2 pi plus 3, and then minus 0 is just going to keep it as 2 pi plus 3, right? Okay, cool. That's a positive number. Now, we probably imagine that, but let's consider what g of 7 is. G of 7 would have to be f of 7 and then minus 7, right? But wait, what is f of 7? We don't have f of 7, right? So here we have to do one more of the things that we did for part A, right? Which is we defined a function from 4 to x, right? And that it was of f prime dx, and this gave us f of x minus f of 4. So here what we want to do is substitute for x in both places where it appears, which is here, and here, like, we want to replace and the dx is attached to d, right? So it's the differential, it's not an x value, right? Okay, so like a 7 here, right? A 7 here, right? And so f of 4 once again was 3. So we have the integral from 4 to 7. That's the area from 4 to 7, right? And so that's like this thingy. There are many interesting ways you could go about finding it. You can find the area of this rectangle and subtract out 2 triangles, that one and this one. Or you can use a trapezoid and a triangle. So like, maybe was hyperbolic, but there are probably other crazier way to do it. Just do it efficiently, right? So this is a base of 2 and a height of 2. So that's 4, and then half of that is 2 in there, right? And this I'm going to do as a trapezoid, or a little square of 1 and a half there. That's perhaps the easiest. I did the trapezoid first time. So what is that? That's 3 and a half, right? So we have 3 and 1 half, right? It's equal to f of 7, which is what we're after, and then minus f of 4, so that's minus 3, right? And it's positive, that 3 and 1 half, right? So then we're going to get that f of 7 is equal to 6 and 1 half, right? Okay, cool, 6 and 1 half. So then what are these critical numbers? Because that's the only thing that's in our way before we say we're done, right? And so that's where the derivative is equal to 0. We've done the derivative for part C, and so what it came out to g prime is equal to f prime minus 1, right? And so we need to know where f prime minus 1 is equal to 0. Like I said there, f prime minus 1 would be the graph of f prime, which is in black here. I'm going to outline f prime minus 1 dotted, but imagine it being solid. It's going to look like this, right? It's going to look like this. And so and we need to set it equal to 0. So the place where it would equal 0 would be like right here and right here, right? And those two, one of those two is already included and as the end of the interval, right? So then we don't need to do it again, but the other one is 5. Oh, how lucky we are, because we already did f of 5, we did f of 5 in part A, and that's going to come in handy, right? Because now we need g of 5, not f of 5. But, g of 5 is going to involve f of 5, so it's going to be f of 5 and then minus 5, right? Okay, f of 5 was 3.5, so that's 3.5. That's 3.5, not 3 over 2, 3.5. And then minus 5 is going to say like negative 1 and 1 half, right? Okay, cool. So negative 1 and 1 half. Well, it's in blue because it's red. It's below 0. It's good. Like, so then it's cold. I meant it's in blue because it's cold. And yeah, so it's below 0. Okay. So it's clear that the minimum value answer the question, right? The minimum value, like. Okay, now they like to present these answers in this tabular fashion, so I imitated. It's just a good habit to get into, blah, 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 but you already took the test too late now, right? So like kids, I guess, who might be interested in this at some other future date. Okay, cool. This is it for problem 3 and problem 4 to come. Oh, have to know it's gonna be on it, like table question and have to know it's gonna be on it, like table question and probably accompanied by the usuals, right? Like, and they start off much the same way that they have in years prior, like years, right? F of B minus F of A over B minus A. Am I saying anything else? No, I don't know, man. Just talking math. No, but like no thoughts. Okay, distracting thoughts enter my head. Okay, voices. Just kidding. Okay. So this okay. So over the interval, like no, but like no, it's for that, right? Now notice this is R prime. This is R double prime. So we're using a secant line on R prime to approximate R double prime. So we want that secant line to be like as tight, nice as possible, around 8.5. And so the two values we'll go with for A and B respectively are 7 and 10. So what that means is R double prime, we're going to say, of 8.5 is approximately equal to, it's going to be negative 3.8 and then minus negative 4.4. And we'll turn that into a plus back-to-back minus, right? Otherwise, divided by what? Divided by 10 minus 7, which, you know, if you need me to write it, like, man, hold you through this, I'll do it. But we all know that that's 3. Like, handwriting is not, so I'm not having a beautiful handwriting day, but it's okay. Like, forgive me, okay? I'll live. I don't know if you will, but, you know, if you cry yourself to sleep, like, I get it. Like, you know, like, sometimes think about it. Some of us are like grown about stuff, so we okay. No, like so part B, right? Okay. Oh yeah, like set units and stuff, use your units. It's like actually maybe interesting to think about, right? Because R double prime, right? R double prime is going to be measured and whatever R prime is measured by over days, right? Because it's like, right? Okay, so like, but R prime is measured in something per day, right? Like they told us, like, so it's gonna end up being like per day. Like, okay, I think like something centimeters squared. You figure it out. Like, I don't know about that unit life. Okay. Part B here is about the intermediate value theorem, right? The intermediate value theorem. And so this is so because, well, R prime of t is the function given here in the table, and we know that R of t is twice differentiable, meaning R prime of t is differentiable, right? But if R prime of t is differentiable, it's automatically continuous, right? And if it is continuous, then we know by the intermediate value theorem that if we have, we don't even need the axes, but I'll draw it like anyway. If we have, let's say, some y value here, let me do it in blue and try to accurately reflect like the situation. So at 0, we're like at negative 6.1, and then at 3, we're at negative 5. So like we're like, let's say here, well, yeah, this is not too accurate, but whatever. Like, negative 5, they're both below the horizontal axis. So we'll live, right? They were at negative 5.0. So basically, like, since, again, by the differentiability of R prime, we know that R prime is continuous, and this graph in blue is supposed to be for R prime. We know that R prime will have to, it doesn't matter how it traverses, like, it could even be like decreasing your bits, it doesn't matter, like, right? It will have to, it cannot climb from this y value to this y value without hitting every y value in between, right? At least once. And so, and so by that, like, we see that the y values here are talking about the RFT values. And so as they go from negative 6.1 to negative 5 in function R prime that is continuous, we know that it had to equal negative 6 somewhere. Yeah, okay, cool. Let's keep moving. quite frankly, I'm almost discouraged from taking any sort of interest in this question because you saw it coming. You had to have seen it coming, right? And it says right, read, and sum, right? With the 4 sub-intervals indicated in the table, blah, blah, blah. Alright, so that's one base, that's another, that's another, that's another. Ooh, hold on, sloppy, but whatever, I'll live. So that's 2 there, that's 3 there, that's 4 there, that's 3 there, right? Those give us the delta x's for the rectangles, and then otherwise from each interval we use the right end. So so the first is going to be 3. That's delta x, right? The width of the interval, and then that's the base of our rectangle, right? And then the height is going to be evaluated on the right hand side since we're doing right Riemann. So we're going to do it's not f, it's r prime, so we're going to write r prime of 3, which we know to be -5, so -5, and then we move on. The next is 4, and then times r prime of 7, that's -4.4, got it. And then next is 3, and then that's the width, right? And then the height we want evaluated at 10, so r prime of 10 is going to be -3.8, and finally we go 2, and then it's -3.5, and you have some slight computational work to do, but it's not so bad, right? We could probably to create some conveniences and stuff, turn some stuff into fractions, and I'll leave it up to you to do that, okay? Alright, cool. So otherwise, let's keep it moving. Okay, so in part D, remember, they described the ice sculpture, is conically shaped, and so, and then they, immediately question that screens related rates as upon us, and so it says the height of the cone decreases, so the height is decreasing at a rate of 2 centimeters per day, so that's -2 centimeters per day, and then, so I guess that's day, D, okay, I suppose, and so that's dH dt, right? Okay, got it. And we need to find the rate of change of volume, so we need dV dt, so dV dt equals what, right? That's the question. Now, so then, the volume formula that they gave us, we need to somehow get rid of R, because, well, R, the radius is not mentioned anywhere, right? We are not given dr dt. We are given dH dt, and we need dV dt. If we also need dr dt, we need too many things for a single equation that we're about to write, right? So to come to the rescue is a little geometry, right? So because they tell us a little bit more, don't they? So if you read on, you learn that yeah, this is a vertical distance and stuff, right? And just we're a little African hut, or American Indian hut, or anybody who needs a hut, right? Okay, cool. And I once, and you don't necessarily have to need it. Just why not? Okay, so this is 50, and the height. Wait, what? The radius is 100 centimeters, and the height is 50. Okay, so with the height is 50, right? So so do we mean the height is 50 from here, right? Or do we mean the height is 50 from here? I'm gonna go with the latter, right? So hold on, or does it really matter? So at time t equals 3 days, the radius is 100 centimeters. Okay, so let's say time t equals 3 days is here right now. So this is 100, well, this is 50, right? Okay, and this is h, and this is r. So then, we see that when we have the value of, h is to r using similar triangles as 50 is to 100, right? 50 is to 100 is the same as 1/2. Alright, so we can write 1/2. And so that means that cross multiplying, we get r is equal to 2h, right? And so then that means that v is equal to 1/3, and then pi, and then r is 2h, so that would be 2h squared times h, right? And so that's going to be pi over 3, and then times 4, h squared times h, that's going to be h cubed, right? Okay, so that's going to say 4/3 pi h cubed, right? Okay, cool. So now that we've got the v in terms of just h, we're good to go because we have 4/3 pi h cubed, and when we take the derivative implicitly on the one hand side, on the left side, we're going to write dv dt, and then on the right side, we're going to have to write 3 times 4 pi, so that's going to get 4/3 pi, so the 3 times 4/3 pi, right, this is going to give us 4 pi. 4 pi what? 4 pi, and then h, and then squared, and then dh dt. Now, to finish, you have to replace dh dt with what you're given, which was like -2 centimeters, because it's going down, that's why it's negative, right? And then h squared, they told us when h is like, at this time, 3 days h is 50, so you do that, and do the number crunching, I'm done. Yeah, okay, cool, let's keep it moving, problem 5 to come. So this is that typical, when it's a slow field question, you know, like it, they go to it every now and then, right? And so, you know, these are supposed to be mini tangent lines that you would have drawn on the original curve. And so, like, you know, like, since you're to draw one that goes through that one right there, like, you know, you want to hug that, ooh, maybe not like quite a turn there, but, you know, it's supposed to be like tangent lines like that. And so you just take them down, without, like, you know, maybe not going off course in that. And this actually, like, I don't know if you see what I see. I see a 3-dimensional thing, a valley here, and peaks there, and peaks there, you know? It's all your perspective, you know? Okay, so you just follow this trend again. What you're not allowed to do, if you haven't heard, is, like, do stuff like that, which is cut through tank lines. Clearly, I'm not done drawing, which is, like, you want to keep going to the left and retrace one cycle of what appears to be a vertically shifted sine or cosine graph. So yeah, all right, cool. Let's keep it moving. Now, okay, so we need the equation of a tangent line, right? Like, and everything is conveniently given us, right? Like, and and then after we find it, we need to use it to approximate f of 0.8. So it's kind of a linear approximation question together with, like, the equation. Well, linear approximation is a tangent line, right? So, like, now we write the equation of a line in the form y minus y1. This is what you should write it in anyway. It's the most convenient. X minus x1 is like, you know, how we finish it, right? Okay. Now we see that since f of 1 is equal to 2, that means that x1 y1 is equal to where should I write it? Like here, I guess x1 y1 is equal to 1 comma 2 is what that tells us, right? And m has to be the derivative dy dx evaluated for the x coordinate, and if we seek a y coordinate, we'll have to, like, include it. So x equals 1 and y equals 2, because quickly looking, dy dx takes in it like both x and y, right? Okay. So now, what is that going to mean? That means that this is going to equal 1/2 sine of pi over 2 times 1. So that's just pi over 2. Sine of pi over 2 is 1, recall. So that's just 1/2 times 1. Got it? And then we'll have this multiplied by the square root of y is 2. So 2 plus 7, I'm like ahead of myself. 2 plus 7 is 9. So we're going to have to write the square root of 9, which is 3. So this is going to come out to 3 over 2, right? Okay, cool. So then that means L minus, that's L for the losers, Freemasons, from which we want to subtract every one of their L minus Y1 is 2. I hate Freemasons. If you didn't know, welcome to the party. Where every chance I get, I try to disrespect them and let them know how much I hate their guts. X minus 1, right? Okay, so that means that L is equal to, why in the world would you like have something as beautiful as Jesus Christ and you choose to worship like a loser like Judas, and like all you do is constantly lose but you never learn? Why in the world would you want? There's like what they're after really is because they're so miserable and they lead such a miserable existence that they want to suck you into their misery because misery loves company. Stick to Christ, okay? Stick to a winner who never loses. All right. So I love, I love X is what this is right now. So I love 0.8 then is going to be like, what's 0.8? 4/5, right? So 3 over 2 times 4/5 minus 1, that's 5/5. So that's negative 1/5, right? This is called thinking ahead. Plus 2. And this is going to say negative 3 over 10. 2 is 20 over 10. So then that together is going to make 20 minus 3 is 17, right? 17 over 10, right? Okay, cool. So that's that. And so next part. What a Freemason feels like to me and what they are like that fourth grader who's always out to prove something, but no matter how much he tries, he can't erase the fact that he's just a pathetic, miserable loser. Yeah. Okay. Let's keep going. So it says f double prime is greater than 0. And remember, like, dy dx is another name for f prime, right? And so f double prime is the derivative of dy dx. So f double prime is speaking on d squared y dx squared, right? The second derivative, right? Cool. So what about it? So we're told that it's greater than 0, meaning our function y is concave up. That's what we take from that, concave up, right? Concave up. Right, got it. Now, so then is the approximation and over, like, well, let's look. So if we draw a curve that's concave up, and then there's a tangent line anywhere to the curve, is that tangent line going to be an under approximation of the function's value or an over approximation? Obviously an under approximation, because you'd be approximating from x coordinates like somewhere down here, and they're all going to hit the tangent line before they beat before they hit the actual curve if it's concave up, right? Okay, so sufficiently explained as far as I'm concerned. Let's keep it moving. I obviously love integrals, but I must love, like, algebra also, because I can never get tired of separation of variables and or preaching about how Jesus Christ is God and he's amazing and he's the only one with power.
True.
So this is like called separating the fake from the real. Also
corny.
Like, getting rid of the weak. So whatever. Like, there are many ways to say it, but like, Jesus is God, Jesus is the only God, no one else has power. They're all bunch of little chumps. Like, I don't even know what chumps means, to be honest, but it sounds like an accurate description of them. Like, they're small and, alright, okay, no. It's pretty vague what I'm talking about. Who cares? Like, I'm writing math, and it's like, I'm separating the variables, and I'm making this more enjoyable. While
that's what I'm talking
very
about.
Important things like how Jesus is God and he's the only God, and how Freemasons are losers. Okay, y plus 2 to the 1/2. Okay, and anyone who doesn't like to follow Christ is in the wrong. Like, you might think it's just my opinion, but I'm allowed to say what is very factual and true. I know what I know, like these separation of variable problems. Okay, how about that? You stick to your domain. I didn't say that I know how to fix a car. I said, I know the Freemasons are losers and Jesus is God. Which is a matter of fact. Okay, equals one half, right? And then it's integral of, and then it's sine of pi over 2x dx, right? Okay. Okay, so like the variables are separated, right? Like none of this is too tricky, right? On the left, we have like y plus 2 to the positive 1/2 divided by positive 1/2, which is the same as multiplying it by 2. And then we have like a plus c1, right? And the reason why we're able to just use the power rule, even though we have a binomial in here, is because if we like make a substitution, say u equals y plus 2, then du is simply dy. So nothing changes really, like if we switch to u. So like, we'll be able to just like quickly recast y plus 2 as u to the negative 1/2. We don't really need that. We could just do this, right? So in other words, no extra details necessary. Now, the antiderivative of sine is negative cosine, because the derivative of cosine is negative sine, right? But then when we take the derivative forward, by chain rule, we would have multiplied by pi over 2, right? But there is no pi over 2, so then we need to like make up for that by dividing by pi over 2, which is the same thing as multiplying by 2 over pi, right? Okay, so what that means is that like, and of course you're going to get another constant here, let's call it c2. What that means that on the left we have 2 and then y plus 2 to the 1/2, and then equals, the 2's here are going to cancel, we're going to get 1 over pi, right? And this negative from that cosine is going to be cosine of pi over 2x, and then plus c2 minus c1. But that's just some unknown constant, so we'll lump them together and just call it a c, right? And maybe you want to like, this c2 minus c1 is like, not really necessary. Okay, and now we know that y is 2 when x is 1, so we can use that right now before we really solve for y all the way. Or we could do it like, so in other words, we can find c now or later. Before square roots and whatever, other things are involved. Let's find it now. So 2 times y is 2, so 2 plus 2, that's 4 to the 1/2. Now 4 to the 1/2 is just 2, right? So, but then 2 times 2 is just 4. So we can come all the way back and see that on the left side we just have 4 equals negative 1 over pi. And then cosine of x is 1 when y is 2, right? Cosine of pi over 2. But cosine of pi over 2 is 0, right? Because on the cosine graph, it starts there, and right? That's pi over 2 right there on the cosine graph. So, well, that means that this whole thing is gone and c is equal to 4. Got it. C is equal to 4 means that we can delete what I have here and that there, and just in place of c write 4, right? And we don't have much left to do, right? I put a 4 there, and now the next few steps are going to be like, divide by 2 everywhere, right? So I could put a 2 right there, and then a 4 over 2, right? So then we're going to have y plus 2 to the 1/2 is equal to negative cosine pi over 2x, right, over 2 pi. And then plus 2, right? Plus 2. And then finally, we're going to have to square both sides, right? And when we do, we'll just have y plus 2 on the left side. So we'll move this on the right, right minus 2. So it's like a weird answer really, but like, okay, yeah, that I'm pretty confident that I did it correctly. So, unless you find a mistake you care to point out to me, this feels just about it. Okay, yeah, all right, let's keep it moving. Question 7. By the way, this is question 7, because we're all about Jesus Christ, and we're all about the sevens.
We are.
As far as numbers.
No lie.
But no,
All day, every day.
we don't like sixers. We call them goat heads, losers, Freemasons. There's all kinds of names for them. Jesus is God. Jesus is the only God. All right. Anyway. Let's get on with it, right? So like this is much the same as like a question from the 2019 FRQ, right? Like very similar. Like gave you a particle P and a particle Q and such, right? Here you need to know the velocity. So they might as well have asked us find the derivative of like this little fellow up here, right? So VP of t is going to have to be equal to x prime p of t. So that's telling us take the derivative ddt of 6 minus 4e to the minus t, right? And so when we take the derivative, the 6 goes away. Thank goodness. Thanks to Christ. And so then otherwise we're gonna write like negative 4e to the minus t times negative 1, right? That was like a weird way to just say 4e to the minus t, right? Okay, so that should be it, right? Yeah. Okay, so that's it. It just says find v p of t, right? V sub p of t. So it didn't say like for a specific t value, so we're done, right? Okay, cool. Next part. Okay, so this is quite a bit of work, right? Like, so first we have to find the acceleration of the particle q, right? So aq of t, let's get on with that first, right? Vq is given the velocity, so this has got to be the derivative of the velocity, so it's v prime q of t, and so that's going to be d dt of 1 over t squared, and so isn't d dt like some kind of bug squares and stuff? Yeah, so it's the d dt of it's going to be t to the negative 2, so it's super random. Okay, so that's negative 2t to the negative, but I wasn't being random. I was very measured and precise on what I said about Freemasons and obviously Christ. Right, so don't confuse jokes with like serious matter. Okay, all right. So now so there we are. So like what then? If we find the acceleration, right? Now look. So we should write this is negative 2 over, and then it's gonna be like t cubed, right? Okay, so like where does the like difficulty come in? Well, we need to know if the speed of the particle is increasing, this particle q is increasing or not, right? Or we need to find the times where t to the right of 0 for like so when the speed of the particle is decreasing, right? So that means that velocity and acceleration need to have opposite signs, right? So signs, right? So when one is positive, the other is negative, or it's negative and then positive, right? So okay, but how do we do that? Because we're not like we like these are not polynomials, not so easy to graph and stuff, right? But like let's consider, and it's not in the calculator section, so we can't just type in our calculator, right? So let's consider, because like we're helped by having to only consider like positive t values, right? So let's consider what like these functions would look like. So they're like kind of like 1 over x, not quite, right? Okay, so 1 over x cubed. Like we could just plug in certain values, right? So that negative 2 is probably going to have it, usually they're like this, right? It's probably going to have it looking like this. So the curve is more like this, right? Okay. Oh man, I could have done that from the beginning, my bad, guys. Okay, so like we got that. So which is this? This is aq of t, right? This is aq of t. So notice it's always less than 0. All right. So is then like sorry, vq of t monotone like that. Also as far as the sign, right? Like all right. So it's 1 over t squared. What do they look like? So still like if we go in 1 over 1, we start with 1, but 1 over 2 is going to give us 2 squared. It's kind of behaves the same way, but like on this other side, right? It's going to look like this time, right? And that, that much we should have figured, right? Okay. So one of them is always like a certain way while the other is a certain way. One of them is always positive while the other is always negative. So this is a V Q of t. So this is always greater than 0. So then it's always, the speed of the particle is always decreasing throughout. So like find O times t greater than 0. So I would say O times t greater than 0, right? Because that's what's happening throughout. Okay, cool. Next part. So I thought that this was one of the 3 tricky questions that I might have like foreshadowed or alluded to much earlier, or whatever, right? Okay, cool. Let's keep it moving. So we need to get to yq of t. Like, so since we're given vq of t, I don't know why they went with yq of t. They should have said xq of t, because usually like x or s is the way we denote position. So I'll actually like go with that. xq of t. Like obviously it's not, the fact that it's not of this particle is clear from this subscript p. So xq of t is going to have to be, which is what they're asking for, is going to have to be involve an integral of like v of t, right? But we have an initial condition that's going to help us determine precisely. So right, like, so we can say the position function like fully determined. So first we integrate the velocity function, so vq of t, right? And so that's going to say like integral of like 1 over t squared, right? And so that's going to be like t to the negative 2, right? dt, right? And so this is going to say t to the negative 1 over negative 1, and then plus c, right? And so we have x cubed of t is equal to negative 1 over t, and then plus c, right? And so using x cubed of 1 is 2, we see that 2 is equal to negative 1 over 1 plus c, which means that c is equal to 3. So this means that this is equal to negative 1 over t plus 3. Yeah, okay, cool. Next. Okay, so for this last question of the last problem, like we needed to recall that xq of t from part C rather, sorry, I'm a little tired, is negative 1 over t plus 3, right? Okay, cool. And we're given xp of t from the start is 6 minus 4e to the negative t, which we can write like this. Now, so we need to send both as t goes to infinity, as the limit of t going to infinity, right? And so like let's make a little bit of space. I should have planned ahead right there, and right lim as t goes to infinity, right? So my bad. So I need to switch away from my cooling thingy. So t goes to infinity, what happens? T goes to infinity, what happens? Well, when t goes to infinity, this is going to explode. It's going to go towards infinity. So flow over something continually growing very fast is going to go to 0. So the limiting value for this is 6. And the limiting value for this is going to be, well, negative 1 over infinity. Well, denominator is going to dominate the numerator. It's going to go to 0 plus 3. So this, we're going to pretend like it's a 7. But it's actually that number that we hate because we love Jesus and hate Freemasons and everyone who, follows a loser like Judas. But anyway, so it's 3-7, okay? But you know what that number is supposed to be. We changed it, right? Okay. We don't have to keep it a secret. If gay people can come out, we Christians can come out again and again. Okay, all right. So that's it. Right? I hope you enjoyed this, and good luck with your future and endeavors and everything else. All right.
Peace.
Yeah, Jesus is God. Jesus is the only God, and Jesus is the only thing to fear. He is the light, the way, the truth, and the life.
True. Have a good one.